Hi, in this video, we're going to do some review problems that cover exponents and polynomials. So first, let's look at this exponent problem, and go ahead and pause the video and try this on your own if you have not already. And we want to get rid of these parentheses first. So we're going to take everything to the third power. So 6 to the third power is 216. We'll put it over here. And you can use a calculator for that if you need to. And then when an exponent is raised to an exponent, or a power is raised to a power, you multiply. Or you could say up high multiply. So 5 times 3 is 15, so that becomes x to the 15th. And then z to the third, because remember this exponent is 1. And then on bottom, let's just leave that how it is. And then our rule for division is to subtract. Before we do that, actually, let's just take care of the numbers. Remember, this is just a fraction, so if we covered the rest of it up, and really kind of think of this as 3 different problems. The first is just 216 over 4. Well, how do you simplify that? Well, just see if it divides, and it does. 4 goes into 216, so that's 54. So 216 over 4 is 54, and I'm going to put it down here. And then now look only at the x's. So I have x to the 15th over x to the 4th. So this would be like having x times x times x 15 times on top, and then x times x times x times x, so just 4 times on bottom. The rule is to subtract with division. And then the bigger number wins out. So 15 minus 4 is 11. And because 15 is the bigger number and it is on top, then 11, or x to the 11th, is going to go on top. And then your last problem you're looking at is just the z. So only think of, how does z to the third over z squared simplify? How does that reduce? Well, everything's going to cancel except for one z, or subtract exponents. 3 minus 2 is 1, and the bigger number is on top, so your z to the first power goes on top. With these complicated exponential expressions, it is a good idea, or expressions with exponents, it is a good idea to break them down and look at them as separate problems, just the numbers and then all the like bases. Okay, number 2 says write a polynomial function that has a leading coefficient of 3, root negative 2 with multiplicity of 4, and root 5 with multiplicity of 1. Do not simplify, leave in factored form. So let's talk about these roots first, and then we'll do the leading coefficient last. So we have a root negative 2 with a multiplicity of 4, and a root 5 with a multiplicity of 1. So if a root or a 0 can be written as x equals. So we have x equals negative 2, and then x is equal to 5. So that becomes root negative 2 and root 5. And then we can turn these zeros into factors just by setting them equal to 0. So I'm going to add 2 to both sides and get x plus 2 is equal to 0, and x minus 5 is equal to 0 when I subtract 5 from both sides. So these are my factors, and I can start to build this polynomial with these factors. So let's give it a name. Let's call it f of x. And leave a little space here because we'll talk about the leading coefficient. But I have x plus 2 as a factor, and then x minus 5 as a factor. Okay, and then you got to address the multiplicity. So this is a multiplicity of 4. That's the number of times the 0 or root occurs, or the number of times the factor occurs. The way you show that is just put an exponent of 4 on the factor x plus 2. And then root 5 has a multiplicity of 1, so we don't write 1 here, but you just leave it 1. This x minus 5 factor has a multiplicity of 1. And then the last thing is a leading coefficient of 3. So the leading coefficient of 3 would be taken care of just by putting a 3 in front. Now, this says do not simplify, leave in factored form, and the reason I chose to do that is because doing x plus 2 4 times and then another binomial here would be a lot of work and more tedious than you probably need to do. So if you need to simplify that, that's a good thing for a computer to do for you, unless you just love distributing. Okay, let's look at a graph and talk about multiplicities. So it says, what can be said about the multiplicity of each root? Okay, so let's look at what the multiplicity or the roots are. So we have x is equal to -5. And notice how this bounces off here. It doesn't go through. We have x is equal to -2. And here's another bounce. X is equal to -1. This one goes through -1. So this one right here goes through. And then it goes down. We don't get the whole picture of the graph, but it loops around like this. Same thing up here. We don't get this whole picture, but it goes up for a while and loops around here. It goes down for a while and loops around. And then x equals 2 is that last 0, and it goes through. So what can we say about this graph? Well, we can say a lot of things, but with the multiplicity, if it bounces off, then it should be an even multiplicity. So bounce is even at -5. So because here it bounces, then the multiplicity is even. Here, this goes through, and so this must mean the multiplicity is odd. And then this goes through, so the multiplicity is odd. And so this is an important connection to make between a graph and the multiplicities. And also when you think about like writing in factored form here. So if we wanted to write like a possible polynomial, you could take all these factors, but you would have to make sure they have an even multiplicity, an odd multiplicity, and an odd multiplicity, or an even exponent here, an odd exponent, and an odd exponent. But we're not going to worry about writing this whole function. Just it would be more complicated to do that. You would need a little more information. The other thing to look at this graph is just to like, when is it above and below the x-axis? So because you know about the multiplicities, you can talk about, well, here, because it bounces off -5 and bounces off -2, it's got to be above the x-axis here. Or just look at the graph here. This is above the x-axis. In between -1 and 2, it's below the x-axis, and then from 2 to infinity, it is above. Okay, here it says to factor the polynomial completely, and you can use a graphing calculator for this, or online calculator, and actually it'll get you there pretty quick. We're going to do the longer version so we can talk about possible roots. So let's look at possible roots. And those are factors of 20, which are 1, 2, 4, 5, 10, and 20. I don't think I missed any. Over factors of 3, so 1 and 3. And so I'm actually going to write these out, although it doesn't ask you to write these out. It's just useful information. You could be asked about it on a different problem. What are all the possible and its rational roots? And so the way you would find those is you just put each number on top over each number on bottom. So it's plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over, not 3, sorry, plus or minus 4 over 1, plus or minus 5 over 1, plus or minus 10 over 1, and plus or minus 20 over 1. And I notice I didn't write the over 1. And then now put all the numbers on top over 3. And these will not repeat at all. So we have plus or minus 1/3, plus or minus 2/3, plus or minus 4/3. And I'm going to go to the next line here, plus or minus 5/3, plus or minus 10/3, and plus or minus 20 over 3, or 20/3. Now, it'd be good to pause the video now and just look at where these possible roots came from. Okay, so we want to find a real root so we can factor this. Okay, so I'm going to use my graphing calculator. You should use your graphing calculator to pick one, or you just have to guess and check. But let's pick 2. 2x equals 2 is an x-intercept on the graph, and you can type that in and see that, or maybe you're just guessing blindly and trying synthetic division. And then we're going to divide. So we have a 3, a -5, a -12, and a 20. Remember, when you do synthetic division, the 0 or the possible 0 goes in the box. So let's get x equals to find what goes in the box. And you bring this first number down, and then we're going to bounce across by multiplying and adding. So 2 times 3 is 6, and then add these together, and you get 1. 2 times 1 is 2, and add these together, and you get -10. And 2 times -10 is -20, and this is 0. I always love a good chance to check my work, because I am one who tends to make a mistake along the way, whether it's multiplying wrong or messing up a sign. And because I get 0, that gives me some confidence that I did something right, because I know this is a root because I looked at the graph, or I want it to be a root, and my remainder is 0, so it divides evenly. So I can take my x minus 2, which is a factor from x equals 2, and write it out front. And then we have 3x squared now. Remember, with synthetic division, you take the exponent down 1, minus 5x, and then, minus x plus x. I was writing from the top and not the bottom. So 3x squared plus x plus 1x minus 10 is equal to 0. Now you could repeat this process with synthetic division again using another 0, or you could use the AC method. So let's do that. Let's look for 2 numbers that multiply to -30 and add to 1, and those numbers are 6 and -5. -30 comes from 3 times -10. Just leave the x minus 2, and then we're going to rewrite 1 as using these numbers. So 6 minus 5 is 1, so I can make that plus 6x minus 5x minus 10. Leave the x minus 2. These factor by grouping. These have a 3x in common, and then a minus 5. And then we have these x plus 2's that look the same. So we think we did something right, and I think we did. So we have x minus 2, x plus 2, and then 3x minus 5. And so that is your factored form. Okay, another thing to notice is if you look at your graph, you get x is equal to 2, x is equal to -2, and then x is equal to 5/3 for your zeros. And so if you want to start there, if you want to start with your zeros, you can just work backwards and say, well, that means my factors are x minus 2, x plus 2, and then you would multiply by 3 and subtract 5. If you have any questions, please reach out, and good luck with polynomials.